Welcome to Summarize Science. Today we are traveling back in time to look at one of the most intense star-forming galaxies ever discovered in the early universe. This is GN20, a galaxy seen as it was over 12 billion years ago. Using the incredible power of the James Webb Space Telescope and the NOEMA radio observatory in France, a team of astronomers has peered into this cosmic nursery like never before. GN20 is what's known as a dusty star-forming galaxy, which means it's a massive factory churning out new stars at a furious pace, hidden behind thick clouds of gas and dust. Previous observations showed it was big, but these new, ultra-sensitive images reveal just how vast it truly is. The new data shows that the galaxy's dust is spread out over a region about 14,000 light-years in diameter. This is far more extended than previously believed, covering the same area as the galaxy's stars and molecular gas. But this led to a significant puzzle for the researchers. When they mapped out the brightness of each component from the center outwards, they saw something strange. As you can see in this plot, the profiles for the gas and the stars are very similar, both broadly distributed. In contrast, the dust emission appears much more concentrated, peaking sharply in the center. So why would the dust, which is mixed in with the gas, look so different? The answer, it turns out, is a kind of cosmic optical illusion. The researchers used sophisticated computer simulations to model how light and energy travel through the galaxy's different materials. This is called radiative transfer modeling. Their model showed that you can have the gas and dust distributed in exactly the same way, yet still end up with these very different-looking profiles. It all comes down to how transparent or opaque the different components are at different wavelengths. The light from the molecular gas is essentially trapped differently than the light from the dust, which makes the dust appear more centrally concentrated even when it's not. The models also provide strong evidence that GN20's frantic star formation was likely triggered by a recent merger with another galaxy. This false color image shows distinct features, like an arm or tail, that point to a violent cosmic collision in its recent past. So, let's quickly recap what this all means. First, the monstrous Starburst galaxy GN20 is even more extended than we thought, with its dust, gas, and stars all spread throughout a huge disk. Second, and most importantly, the apparent size and shape of a galaxy's components can be deceiving. What we see is not just the distribution of matter, but also how light interacts with that matter on its way to our telescopes. This is a critical lesson for astronomers studying the building blocks of galaxies in the early universe. It shows that to get the true picture, combining powerful observations from telescopes like JWST and NOEMA with advanced computer models is absolutely essential.